In a previous video, we've talked about Plainsight benchmarking and how we use the optimization loop to continually improve the accuracy of detection of objects within videos. In this section, we're going to dive a little bit deeper into Plainsight benchmarking and show you really in detail what the optimization loop involves. We're going to start with the same example. So this is a Vision AI pipeline, a VisOps pipeline that's taking video input from a camera. It's using a video in filter. Remember that filters go to make up our VisOps pipeline. And it's processing that video. And here we have our car detection filter. So this is a filter that is able to detect cars within a piece of video. That'll pass that through into what we call the web viz. That pushes the video out, complete with the annotations, so where the cars have been identified or labeled, right? Maybe identifying the car, detecting the car. We may be reading the license plate, for example. We can do multiple things on that, but where we've detected the car, we can annotate that video and then publishing through the web filter such that it is visible through a web browser or some other tool. And again, from that, we can get data. So how many cars have been detected, what time they were detected, what type of cars, red cars, blue cars, all sorts of data that we can get out of that. I want to dive into this part in more detail. So this is the filter that's doing the detecting. I explained that we have, as part of this, a model. It is the model that is detecting the car within the video. How do we build that filter complete with the model? We do so actually in a two-stage process. So we'll start with a model, and this could be a SAM3 model, for example. It could be from Hugging Face, right? Multiple different places, multiple different models. But we, you as the customer, will choose an appropriate model to begin training. From that, you'll create a data set. It is that data set that actually goes to form the model that is used within the car detection filter. But what happens when we experience drift? It may be that a human looking at this output sees a car that hasn't been detected by the Vision AI application pipeline. And that could be because the sun is shining. It's creating different lighting conditions. It may be a type or style of car that hasn't been seen by the filter previously. And so what that drift creates inaccuracy within the pipeline. This is one scenario that can occur, drift. The second is, and I'm just going to call this new tech. New technology comes along in multiple different shapes and sizes and flavors. It might be new models, so it may be up here, right? Who knows? Maybe a SAM4 model, right? But a new model that actually offers improved detection or is able to detect other things of interest within the same model. It may be new hardware, right? That's being used in the premises where the cameras are deployed. So whether it's drift that occurs as a result of environmental changes, or whether it's new technologies you wish to be able to take advantage of to, again, further improve your Vision AI application, you need a way to be able to understand how do we rebuild this, and then once we've made the changes, is it delivering the results that we want, right? Is it actually offering an improvement? Well, how have people done that previously? A lot of that is gut feel, right? It's somebody looking at the screen and saying, yeah, I think that looks better. There's a lot to be said for that, but it's not hugely scientific. What we really need is a system of benchmarking. So if we have our VisOps pipeline, again, to be consistent, we have, in this example, video in, we have car detection, we have WebViz out, then we get the result. And of course, previously we've been showing that on the screen, but it could be data, it could be different forms. Let's say that we have a new model available, right? Our new model is available, and we want to understand, is this going to be better or worse than the model we're currently using in the car detection filter? Well, the way in which we do that is we'll take that new model, we'll do a bit of training on it to get a data set. Right? So to understand whether it's worth using a new model, first we need to establish something we call the ground truth. Now the ground truth is, if you like, the verified or validated result. This is the standard by which you want to compare all others. Now that could be something that you could create manually, so you could go and annotate or detect the vehicles yourself and mark up a video appropriately. Or again, we can automate that through automatic ground truth generation. But you need the standard by which others are measured. And that is the ground truth. To do this, we'll use Plainsight benchmarking to now create a secondary pipeline. Exactly the same video in, same car detector filter. However, in this case, we are using the new model, right? Remember, we had our new model, say perhaps it was SAM3, perhaps it was something else, SAM4, to generate the data set, to generate the new model, and we're using here in the car detector filter in place of the previous one. Same WebViz filter out, and then we'll see the results. Plainsight benchmarking runs a test against both of these VisOps pipelines, pipeline 1, pipeline 2. And it compares at a frame-by-frame level what is detected in each of these pipelines against the golden truth, the GT here. Then it gives you an output. It gives you the results. And that is based on an accuracy. So we could say pipeline 1 achieved a 93% accuracy. Pipeline 2, using the new model, achieved a 95% accuracy. So we know the implementation of this new model, accuracy of this system has improved. That's a win. But here's the great thing. We don't just do this against 1 or 2 pipelines. We can do it against 3 or 4 or multiple. So all the various different permutations of changes that you can make to hardware, to cameras, to different models, you can benchmark all of those different combinations in your pipelines to understand what is the optimum solution for my use case. This process, taking a pipeline, a Vision AI VisOps pipeline, comparing that against the ground truth, the known good version, and comparing other pipelines, multiple pipelines against, using different combinations of technologies, different models perhaps, different cameras, different hardware, different programming logic, is really what helps us create this optimization loop. Using this continual process, taking new technologies, feeding them in, analyzing the results, determining Is it a change we implement or not? Allows us to optimize our use cases and ensure accuracy is being maintained or even exceeding the required levels. If you'd like to learn more about how Plainsight and Plainsight benchmarking could help you improve the accuracy of your vision AI systems, visit plainsight.ai today.